Hello everyone, myself Twinkle Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In this video lecture, we are going to discuss Wrangling data part 2. So first of all, we will discuss the EDA approach, measuring the central tendency, measuring variance and range, working with percentiles, defining measure of normality, understanding the frequencies, inspecting box plots, observing parallel coordinates, graphical distributions, plotting the scatter plots, and how to use the covariance and correlations. So first of all, we will discuss the EDA approach. That is, exploratory data analysis is a general approach to exploring data set by means of simple summary statistics and graphic visualization in order to gain a deeper understanding of data. EDA helps you become more effective in the subsequent data analysis and modeling. EDA describe your data, closely explore the data distributions, understand the relations between the variables, notice unusual or unexpected situation, and place the data into the groups. And also notice the unexpected pattern within the groups. Take note of the group difference. So now we will discuss how to measure the central tendency. During your explorations, you use a simple but useful dataset that is used in the Fisher iris dataset. So we are going to use the iris dataset. We can load it from the scikit-learn package. Using pandas, we can quickly compute both the means and medians. Here is a command for getting the mean from the iris data frame. So the command uses iris data frame dot mean, which is used to find out the mean of the iris dataset. Next, similarly, we can also find out the median of our data set. So this is the output of the median of the iris data frame, and the median provides the central positions in the series of values. When checking for central tendency measures, we can also verify whether means are zero. We can also check whether they are different from each other, and also notice whether the median is different from the mean. Next, we can calculate the variance by using square root of the standard deviation. The variance is a good indicator of whether a mean is a suitable indicator of the variable distribution because it tells you how the values of a variable distribute around the mean. The higher the variance, the further you can expect some value to appear from the mean. So this is the example how to find out the standard deviation or the variance of the data frame using the .std function. Next is how to find out the maximum and minimum value using the .max and .min function. Now we will see percentiles. Because the median is the value in the central position of your distribution, you may need to consider other notable positions. Apart from the minimum and maximum, the position at 25% of your values and the position at 75% are also useful for determining the data distributions, and they are the basis of an illustrative graph called a box plot. So we can see the output as a matrix, a comparison that uses quartiles for rows and the different dataset variable as a columns. So to get the percentiles or quantiles, use the command .quantiles and pass the parameter as 0, 0.25, 0.50, 0.75 and 1. So this is the output of this command. Next we will see skewness. Skewness defines the asymmetry of data with respect to the mean. If the skew is negative, the left tail is too long and the mass of the observations are on the right side of the distribution. If it is positive, it is exactly the opposite. So kurtosis shows whether the data distribution, especially the peak and the tails, are of the right shape. If the kurtosis is above the 0, the distribution has a marked peak, and if it is below the 0, the distribution is too flat instead. So now we will see how to obtain a frequency or the number of values for each category variable of a dataset, both for the predictive variable and for the outcome by using the command .value count. So the resulting frequency shows that each group is of the same size. Frequency can signal a number of interesting characteristics of qualitative features, the mode of the frequency distribution, that is the most frequent category, and the other most frequent categories, especially when they are comparable with the mode or if there is a large difference between them. The distribution of frequency among categories is rapidly decreasing or equally distributed. Next is inspecting box plots. Box plots provide a way to represent distributions and their extreme ranges, signaling whether some observations are too far from the core of the data. So following code shows how to create a basic box plot using the iris data set. For that we have to use the command iris data frame dot box plot. So this command will show the box plot of the iris data frame. Next, we will see observing the parallel coordinates. Parallel coordinates can help spot which group in the outcome variables you could easily separate from the other. It is truly multivariate plot because at a glance it represents all your data at the same time. The following examples show how to use parallel coordinates. For that, we have to use the command parallel coordinates, and we have to pass the iris data frame. So this shows the represent the all your data at the same time. Next is graphing distributions. Histogram present the more detailed view of the distributions. So following figure, this figure shows the histogram of the petal length. It reveals a gap between in the distribution that could be a promising discovery if you can relate it to the certain group of iris flower. For that, we have to use the function variable dot plot and kind. We have to assign the hist value to the kind parameter. Next is plotting the scatter plots. It compares the length and width of the petals. The scatter plot highlight different group using the different colors. The elongated shape described by the point hints at a strong correlation between the two observed variables, and the division of the cloud into the groups suggests a possible separability of a group. So this is the scatter plot program for the scatter plot, and for that we have to assign kind equal to scatter, and we have to give the value of the x and y parameter as well as the colors array. Next is covariance and correlations. So covariance is the first measure of the relationship of two variables. It determines whether both variables have a coincidence behavior with respect to their mean. So, if the single value of the two variables are usually above or below the respective average, the two variables have a positive association, and it means that they tend to agree, and you can figure out the behavior of one of the two by looking at the other. So in such cases, their covariance will be a positive number, and the higher the number, the higher the agreement. And if instead one variable is usually above and the other variable is usually below to their respective average, then the two variables are said to be negatively associated. So even though the two disagree, it is an interesting situation for making prediction, because by observing the state of one of them, you can figure out the likely state of the other. So in this case, their covariance will be a negative number. A third state is that the two variables don't systematically agree or disagree with each other. So in this case, the covariance will tend to be a 0, a sign that the variable don't share much and have independent behavior. Next is computing a covariance matrix is straightforward using the pandas. You can immediately apply it to the data frame of the iris data set. So for finding the covariance, .cov function is used, which will indicate the covariance among the data. Next is correlation. Correlation, which is the covariance estimation after having the standardized the variables. Here is an example of obtaining the correlation using a simple pandas method. For that, .corr method is used. Thank you.